Welcome to Module 5. In this module, we will break down BOS cost, the balance of system cost, and understand how electrical, mechanical, civil, and soft costs influence total project cost. BOS cost often exceeds module cost because it includes everything else required to build a PV system. Engineers can significantly reduce BOS cost through smart design choice. BOS stands for balance of system. It includes all components except modules and inverters. BOS is a major cost driver and often determines whether a project is financially viable. BOS cost is divided into 4 categories: electrical, mechanical, civil, and installation, and soft costs. Each category contributes differently depending on the project type. Electrical BOS includes DC and AC cables, connectors, conduits, combiner boxes, junction boxes, and protection devices such as fuses, breakers, and surge protection. Mechanical BOS covers racking, mounting hardware, rails, clamps, fasteners, and foundations, such as piles or ground screws. Tracker systems, if used, significantly increase mechanical BOS cost. Civil and installation costs include trenching, conduit installation, foundations, labor, equipment, and site preparation. These costs vary widely depending on soil conditions and layout. Soft costs include engineering, permitting, project management, and commissioning. These are often underestimated but can represent a significant portion of total BOS cost. BOS cost can exceed module cost and is strongly affected by engineering decisions. Optimizing BOS is key to improving project economics. Major BOS cost drivers include cable length and sizing, racking type, site layout, labor intensity, and trenching distance. Engineers must balance performance with cost efficiency. In rooftop systems, DC cable runs are short, reducing electrical BOS cost. However, installation labor is higher due to rough access, safety requirements, and complex mounting conditions. Ground mount systems require long cable runs, trenching, and conduit installation. Mechanical BOS is higher due to pairs or ground screws, but the labor cost per kilowatt is lower. Engineers reduce BOS cost by optimizing string lengths, minimizing cable runs, choosing efficient layouts, and standardizing components. In summary, BOS includes everything except modules and inverters. Electrical, mechanical, civil, and soft costs all contribute to total project cost, and engineering decisions strongly influence BOS cost. In the next module, we will learn how to match arrays to inverters and ensure long-term performance. This is one of the most important parts of PV system design. If you are enjoying this solar engineering series, feel free to like the video, subscribe to the channel, and share it with anyone learning solar engineering. Your support helps me keep building high-quality engineering content. Thank you for watching Module 5. I will see you in the next video as we continue building your solar engineering knowledge.